All right. We're going to continue our discussion about the sine, cosine, and tangent graphs. Um, I've been kind of giving to you all the different pieces of how you can transform this graph. We talked about the A value, aka the amplitude, the D as in dog value for the midline, so moving it up or down, the B value as in Bob for stretching or compressing the graph horizontally. So the last thing we're going to do is talk about the C value. And I'm going to show you something that some of you may have figured out. So we're all aware what A, B, and D do. And we should have an idea of what C does to a graph based off of our knowledge from Unit 1. So this is our typical sine graph. This is a 1 sine of 1x minus 0, so sine of x plus 0, right? So typical. You should know that the A value stretches your graph up and down. So vertically, that's a stretch right there. You should also note that when you have a negative value, notice right here in this area that the graph is decreasing instead of increasing when you have a negative A value. And the D value changes that midline. So right here in the middle of the graph, in this case, it's the x-axis. That's the midline. But if I make D a positive number, notice it's taking the whole graph and moving it up, midline included. So instead of the middle of the graph being at y equals 0, it's now at y equals 6, which is that 6, which is that movement right there. We also have the B value that can horizontally compress the graph, or it could stretch it out. In order for me to stretch it out, I need to make sure that I have values that are less than 1. And actually, I'm going to avoid using -1 because that's something a little complicated that I don't want to get into just yet. So notice that as the B value gets closer to 0, the graph kind of flattens out, it stretches out. So kind of like we were doing with our Unit 1. When we have a B value that is between 0 and 1, your graph will horizontally stretch out, right? So that means it takes longer for the period to be completed. As I get closer and closer and closer to 1, I have a return to normalcy there, right? It takes from 0 to 2 pi to complete one cycle. So then if we make it 10, then this should just compress horizontally. Notice how it's not moving the graph up or down or stretching it up or down. It's just bringing it together like a spring, so to speak. All right. Now let's talk about C. So here's what C does, and we call it the phase shift. I've made it so that every time I move my cursor, it's going to move my graph by pi over 6 units. And right now, it's x minus C. So when I have a C value of that's 1 pi over 6, I moved it one space away from 0. Okay. 2 pi over 6, aka moving it pi over 3. This right here is pi over 2. So notice, this point at 0 comma negative 1 used to be over here. But when I move it, when I make the c value 3 pi over 6, this point moves from negative pi divided by 2, comma negative 1 to 0, comma negative 1. I feel like I've seen this graph before. Okay. So it took this point that was here and it moved it to the left. Psych, I know my directions. That moved it to the right. Gotcha. So if I have a c value here that's being subtracted and it's like I'm subtracting a positive number, that moves my graph to the right. If I'm subtracting a negative value, so right there that would be a negative pi over 2, I subtracted that and it moved. Okay, hold on. Let me double check. 1, 2, 3. Okay, so it moved this point at pi over 2, comma 1. That gets moved to 0, comma 1. I feel like I've seen this graph before as well. Interesting. So like, I'm being coy because sine and cosine are essentially the same graph. There's sine, here's cosine, right? And I'm going to take away the minus c component so we don't see how it shifts. So if I want to try and transform a sine graph into a cosine graph, okay, 1, 2, 3. Turns out I have to add pi over 2 to the x value in here, right? So if I change this to x plus pi over 2 because I'm subtracting this negative, turns out it lines up exactly with a cosine graph. So that's why it's sine and cosine, because it's the same behavior and we can make them look the same. In this instance, if I just add a pi over 2 to the input, right? But here's something I need you to consider. Well, what if I change the b value, right? Because the b value can either stretch or compress my graph horizontally. And I know that based off how much I add or subtract, I can move the sine graph left or right. So what if I had a 3 pi here, right? So let me reset this back to 0. If I want to move this back over here, I would have to add, because I needed to move to the left. Hopefully that was left. I'm not sure how the camera works for you guys. Psych, that's the wrong number. I would need to move it to the left, pi over 6. So notice, when b equaled 1, turns out that sine of x plus pi over 2 could equal cosine of x. And when b is equal to 3, turns out I'd need to have a sine of x plus pi over 6. Come on. to equal a cosine of, so close. That would change a sine of 3 times an x plus 6 equal to a cosine of a 3x. Okay? So think about what effect the b value has on determining what the phase shift should be if you want to transform a sine into a cosine. So I'll leave that up for a reflection post. So now that we've done that, well, what if I wanted to go the other way, right? What if I wanted to make cosine look like a sine graph? Yeah, let's move this back down to 1. Let's start simple, okay? If I want cosine, move this back to 0. If I want cosine to turn into a sine graph, right? I want the blue to move to the red areas to overlap it completely. I need it to move to the right, which means I need to subtract a positive amount. 1, 2, 3. Take 3. So it turns out that when b is equal to 1, cosine of x minus pi over 2 would equal sine of x. So based off that, if I make b equal to 2, I'm going to take a guess. Nah, psych. 2 is so boring. Let's make it 5. Let's make it 5. I would say that it would take cosine of x minus, oh boy, pi over 10 to equal, don't forget the 5. You can't forget the b value, Rodriguez. You gotta be better. Gotta be an example for these childrens. I'm going to say that cosine of 5 parentheses x minus pi over 10 should equal a sine of 5x. Right? So I'm going to get rid of all these sliders because the sliders don't count by pi over 10. All right. So I'm saying cosine of 5x minus pi divided by 10. And I wanted sine of 5x. So think about what I did to figure out this phase shift right here, given that I knew this relationship here and I had a new b value, right? And I'll post the next video kind of showing you how to do a little bit of work with some of this to identify the amplitude, the b value, so the horizontal compression or shrink, compression or stretch, the phase shift, and the midline change. Good luck.